All right, afternoon, everybody. I hope you are still enjoying the lectures from today. So we're on the last one today. This is, I think, it's the fourth one. I'm not entirely sure. I'm pretty sure it is. But just a little bit about me, because I know I've switched over from Esther. So my name's Rachel Alderson, and I am a concept artist and also a lecturer on the Concept Art for Games and Film course as well. And today I'm joined by Greg, who is a course director for games design here at Staffs, and he's going to be giving a talk on Introduction to AI in Unreal Engine. So I will hand over to you, Greg. And you are free to go whenever you're ready.
Lovely. Cheers, Rachel. Welcome, folks. I'm Greg Penninck, and I'm the course director for games design at the university. I'm also an authorised Unreal instructor partner for Epic Games, and as part of what I get up to is I work a lot with Unreal in both the design and the art teams at Staffs, and you're more than welcome to check me up on our website to see what I get up to and what I get involved in. So for today, what I'd like to talk to you about is AI and AI within the Unreal Engine. So we're going to tread through a couple of different things. We're going to be looking at how we can work with detection in Unreal, so understanding the world around us as an AI. We're going to look at how we can start formulating decisions and then coming with actions. And these three things help form backbone of what maybe any AI might want to do in games. So there we go. We're looking at trying to understand what detection is first. So it's looking at, is there a threat in the world? Is there something we should react to? Maybe there's a stimulus in the world, a sound effect, a target, something that we want to perhaps understand as an artificial intelligence system. We're then going to take that information and try to create a plan. And we'll need different ways of working with all of this information in our game systems and then actually act on it. So whether or not to chase a player, attack something, go and find a resource, do something cool in our games. And with that in mind, a part of what I wanted to talk about was, well, how does all of that connect into Unreal? How can these three things be connected into the Unreal Engine as something cool? So inside of UE4 and UE5, there's some absolutely amazing systems that you can work with, and they're all built upon these two main classes to start off with, and that's controllers and characters. So if you've not come across these before, you can think of controllers as the brains, and this will be housing a lot of the latent functions that we'd expect to see in an AI system. Again, maybe the movement when something is created or spawned, that sort of thing. And then we have characters, which is actually the physical avatar of the character in the world. And here we might look to draw skeletal meshes. We might be looking at animations, particle effects, all different kinds of components, character stats, that sort of good stuff. And most of the systems are going to be built off these two classes to begin with. And what's really nice about this is we can add more and more complexity to our systems to help with this decision-making process. And so if we look at detection as our first sort of point, then detection is really, really nice inside of Unreal Engine. And what we can do is we can use a component called AI perception. And this will work with the world around a character, and it provides designers and developers with senses. And there's lots of different ones that we can explore. We can build an array of these, so our AI can have multiple senses to help them understand the world around them. And it gives designers lots of parameters to play around with, which is really cool. So we can control how far you might see a target, how far away we might hear a target. There's lots of ability to control things like debugging, which is really nice too. So there's a big wealth of features in this component, and it helps our systems really understand what's going on in the world around them. And when you start to dig deeper into this, folks, we can build upon different senses. So often folks go for sight as the first one, and this will be looking at things like field of view and radius to try and understand where our targets are in the world around us, which is really super awesome. But it's often the combination of all of these senses together that helps produce a bit of richness to the AI. And to avoid kind of a cartoony kind of villain in a game. So building up these senses so that your designs have several of them is really helpful to making something that's a little bit more detailed and a bit more developed, which is very cool. And when you start with this, I always recommend folks to be digging into planning software. So before getting your hands too dirty inside of a game engine and building too many systems, it's often worthwhile trying to go into diagrams.net, Excel, Photoshop, or something like that, so that you can lay down a bit of a flowchart of what it is that you might want your AI to do. Because there's nothing worse than getting halfway through it and then having to rip it up and go, I didn't actually want it to work like that. And ultimately, these senses get fed into Unreal's behavior tree system, which is what controls much of the complex AI that you see in games, and particularly in Unreal. So, in terms of how we might do that, then perception often will have a number of events in our character blueprint, and these events will be automatically updated by the sensors that you plug into your system. And what's really nice from this is that we can take our actor stimuluses, we can break them apart, and we can compare lots of different variables and properties about our AI perception, which is amazing. So Unreal gives you all of this very much for free. So you're able to know when something was last seen, where it was, if it had any tags, and you can also get the particular type of stimulus class as well. So you can see whether it was detected via sight or hearing or all of these sorts of things. And this is where often you would build that first stage of the system where you would have a target perception updated event, and then you can fire off the logic from there, which is really cool. So having this for free effectively built into the engine is incredibly powerful, and it allows you to build nuance. Now, this sort of event is brilliant straight out off the bat if you wanted to do something like sight and you just wanted to track where a target was and have a very easy event that reports whether or not something's been tracked. But if we wanted to do something that was more complicated, we wanted to look into sound, we wanted to look into damage, we wanted to look into touch, or these different things that Unreal offer us, then we do need to connect into some other events. So Sight is very much automated with the event on the following slide. It's very sort of out of the box, it's going to work. However, what we need to do as AI designers is we often need to link in with animation and audio and all of these other sorts of systems that connect into Unreal. So, for example, with the two uh, events on the slide here, these two we'd want to connect into audio and perhaps your combat system. So in order for the AI to hear you, what we would do is we'd use the report noise event, and this would tell the AI where something's heard. What's really cool is if we work with our animators in this case, we can get footsteps or we could get animation notifies that would then tell Unreal when a noise is heard, which is really, really nice. Likewise, if we wanted to make our AI understand and react to damage, then we could work with our combat designers and make sure that the report damage event is played at a point of damage. And this is great because maybe we want an AI gets hurt and then that affects where it looks or what it does next. And all of these together start to build more detailed and rich experiences. And you've probably all played games yourself where sometimes the villains seem a bit Scooby-Doo like and they chase you aimlessly, but there's nothing much there in terms of overall complexity. And it's all of these different little subsequent events together that feed into Unreal's AI perception component that creates just this really rich understanding of the world. Now, you can go a bit too far. You can end up modeling too much of this. You can, not every sort of character or AI that you build needs to have all of these different events and senses. Sometimes you do want something to be quite simple and basic and just an easy threat to overcome. That's fine. But perhaps you want to build a boss or a harder enemy, or starting to drip in these different types of reactions and events really does help to make your AI just that little bit better and stand out. Because ultimately, when we're creating AI for games, we want to create something memorable, something fun for our players to overcome and defeat. So all of this is to create information that is then passed through other systems, whether it's sight, noise, damage, touch, all of these different events. We're passing information. As you can see on the slide at the moment, there's location there, there's ranges, there's tags, all of these things. But where do we pass this? Okay, so we use our character and we use our perception component to track what is going on in the world, but where does this data go once we've got it? So Unreal has a really powerful system inside of it called a behavior tree. It's quite common in many different games out there at the moment, but Unreal has a really lovely visual editor for this, which does make the process fantastic to work with. Now, behavior trees is a visual nodal system, and if you're working with Blueprint, it's going to feel very much like everything else that you build, which is really cool. But there's a lot to pick apart and kind of learn. So when you look at a system like this and you see a diagram, there's all these different colored boxes and nodes, and what does it do? How do we get the most out of it? So to start off with, one of the things that I would always recommend folks to try and figure out is what information do we need to actually give our system. So if we're trying to make a decision, whether it's to chase a player, to attack a player, to patrol an area, all of these sorts of things require information and variables for them to work. And we can do that with behavior trees in a couple of different ways. But blackboards is probably the starting point for most folks. And blackboards are a special type of object for a behavior tree that house these really key important variables. And these you can populate yourself. The ones that are on the screen at the moment are just a couple of examples of things that I've tracked in systems before. And it means that you can easily populate these as your AI is going about its business and control what is going on inside of Unreal. And this you can find nice and conveniently hidden to the top right hand corner of the UI, and you can add to this. And again, thinking about what is it you might want to track? Well, what system information do we want to pass through? Perhaps you might want to pass through a target. So where you want to move to, you might want to pass the target itself. It's helpful to know the thing that you might want to fight or run away from. Maybe your AI is fleeing. We might want to check if we're in a particular state or a particular animation has played. For example, are we attacking? That sort of thing. So these blackboard keys are often one of the first things that we start to figure out when we're working with this technology is what information are we passing through. And the graph itself, the actual behavior tree itself, starts with a root, and that root then we build lots of other composite nodes onto. And this is where you get some choices. So often one of the first composite node that you're going to use is called a selector, and it does very much as you'd imagine. It selects what to do next. So to do that, you're going to have to normally come up with maybe some maths, a bit of blueprint or script to try and understand the decision that your AI might make. So above there, what you can see is we've got this selector node with a green box. This is called a service, which we'll look at in a bit. And the selector will decide which of those three branches will play next. And this is where, again, some of the richness of your AI systems can really come to life, because what we're able to do is we're able to pivot these different branches depending on our Blackboard data, depending on particular decisions as we go through the tree, which is why it's so fun to kind of build these systems. Now, as you go further down the behavior tree, you're often going to end up with a sequence node, and it kind of does what it says. It plays things in a particular order, and that can be helpful when we're trying to create a recipe or almost like a shopping list of what we want our AI to do. So in this particular case, what's happening here is we've got an AI that's rotating towards a target, it's pausing, it's then going to move, and eventually it's going to stop investigating. So this actual sort of state you'd see in many games today, maybe when a player makes a noise and the AI will often look towards that direction, but they don't necessarily know where the player is. So we've got this sequence here of different sorts of tasks which are being played, which is allowing the AI to basically go and investigate just to see if there's anything there. And we're able to build in a bit of a delay with the wait notes. We're able to put move commands in so that we can actually do pathing for our characters. So it's a very sort of powerful way to easily communicate what you might want an AI to do, which is just awesome. So sequences, often we need to carry out something kind of complex. That's what we would use them for. Now, in terms of figuring out then some of the decisions, we often work with the service node, and this is often a node that's going to be executed very frequently through AI tick. And this is often the case when we need to do something that's very complex. It needs a high level of accuracy. So, for example, the particular service on the slide at the moment, we might branch off into different particular parts of the behavior tree if a condition is met. So, for example, if we're close enough to a character to attack, let's do that. If we're not close enough, maybe we should chase them, or even if we can't see them, maybe we go back to patrolling. So the service node allows you to make that kind of decision, and often I'll be using services to update Blackboard keys that are based on the gameplay at the particular time. So generally speaking, you want to be using these for anything that's got really high level kind of accuracy that's required. And the more complexity that you put in here, the more performance hungry your system will end up being. So you certainly want to balance really what you're trying to do with these so that it doesn't get out of hand and you don't end up doing too many things at once. So it's certainly not a competition to make 25 nested if statements all over the place. You have to be careful. Now, further to that, if I just go back a couple of slides, you can see that when our services are kind of connected, we've obviously got these branches and we've got these blue boxes then on top of our sequence nodes, and these are called decorators. Now, what this allows us to do is to check for a particular gameplay condition, and that will then allow us to either run the next bit of the tree or to abort it. So, for example, there's no point trying to patrol if we don't have any patrol points. There's no point trying to attack if we don't have a target. Those sort of statements, they're very much the result of kind of the gameplay conditions at the time and linking in to our Blackboard keys, which is really powerful. Now, what's nice about decorators is that Unreal does ship with a bunch of existing sort of code here, which is really nice. So we can have a look at things like cooldowns. We can look at time limits and looping and all of these things if we need to get a particular behavior to play again and again, or if we just need to modify something a little bit, which is quite nice. So these will kind of go in place before a system does its action. It's often the last thing that will run just before we get an action. And that is often handled by tasks, and tasks are the purple nodes in a behavior tree, and there are many of them. You can make your own inside of Unreal 2, which is great. So again, this might be things like pauses, it could be things like moving, pathing, rotating, or you could create particular tasks for playing an animation or for triggering something in particular that may be a special ability, for example. So these will often come off the sequence composites, not always, but often. And they were going to handle the actual response to a decision and actual action in the game. So that's what these are for. And they can do all sorts of fun stuff as well. We can use them to update a character's set of properties and parameters, which is really nice. So sometimes what we might want to do is, as we go into a particular state, we might want to make the character faster. So, for example, if we've decided to chase a target, we might want to have a task that increases our speed before we try and chase after them. And likewise, if we go maybe into a patrol state, we might want to slow down the AI so that it moves more leisurely. So these tasks are great. You've got a lot of freedom here as to what you can do with them. However, they can come with some issues. You have to be kind of cautious with them. So you want to keep an eye on your execution paths when you're working with tasks. So in this particular case, what's happening is that when this event executes, it is updating the speed of a character. And when it finishes, it's got to finish execute to say, I'm done, I'm finished. This task has gone well in this case. However, you do need to be mindful of also any fail conditions. So in this particular case, there is a cast there to check a movement component. And if that doesn't go well, so if it fails, we also need to make sure that it finishes as well. So what can happen here is your systems can get a bit stuck if you're not being mindful over these execution paths. A very sort of simple thing to keep mind of is just make sure that any kind of execution path is managed so that you don't have any kind of holes, lulls, or sort of problems with your systems, really, as sometimes these can be quite fun to debug. So making sure that I guess you finishing all of your executions is a good thing to keep in your mind's eye. Now, in terms of bugs and failures, then your behavior trees can go wrong in lots of different ways, and that's okay. But what we need to do is we need to be careful how we debug this and check them. So, what's lovely about the Unreal Engine is that behavior trees, we can debug them by using our @ key. But what we need to be mindful of is that if we want to see what's going on in a character's mind, is that we need to be by them when we try this, and we actually need to be playing in game. So on the screen at the moment, there is a character which I can see and I'm close to, and when I press the @ key, we can see the character's perception components. We can see their pathing. We can see some of their variables from the behavior tree, which is amazingly helpful. And that gives us a bit of a picture of what's going on inside of our AI's mind. And this helps us as a designer or as a developer to really know where problems might exist in our system. Now, in terms of how this works, then as soon as you've hit the @ key and you've gone into your character's mind, you can then use your num key to toggle all of these things on and off. So in this particular instance, then, if you didn't want the nav mesh, I could hit 0 and it would go away. Likewise, if I just wanted to debug perhaps the perception of a character, I could hit 4 and it will show me what the character's seeing. So the diagram here in the screenshot, then I can see this faint green cylinder that's going around the whole area where that AI can see the character, which is cool, and that's helpful to us as a developer because we might want to be able to balance our character's vision. Maybe they see too far, they see too little, and this gives us the tools straight out of the fresh install to be able to do that, which is amazingly helpful. So often what you'll be doing is you'll be developing your behavior tree, building up your blackboards and your detection systems, all of these things, and then you'll be hopping into Engine, playing and seeing if that has come across through the debugger. And with anything like this, there's going to be pitfalls. So a few things and some conclusions to keep in mind as you kind of go through. It doesn't have to perfectly match reality, and it might sound obvious, but the AI doesn't have to master everything. when you're building characters and you're building challenge for your game, you've often got to work with your design team to think about what an AI is actually doing in your game. What is the need? What is the requirement of that AI? What are they affording your game? So figuring that bit out first is kind of important, and don't feel that every AI has to do everything. It's not the case. We've got to be careful that we don't make them too powerful. It's very easy to give AI what we'd call domain knowledge, which often is the case where we might play a game and there'll be an AI that can see you from a mile away. They'll be too fast, they'll be unbalanced, they'll react just poorly and break the game. So we've got to balance our kind of systems as a technical designer or as a designer to ensure that it is actually balanced. Somebody has tried it, it does work properly. We've got to be careful how we make these systems so that others can balance them. So keeping a pattern of development is important as well. Thinking about what kind of variables are you creating? Where are you placing them? How do people know what to adjust? If they want to tweak the AI's sight radius, if they want to tweak the AI's speed, they want to tweak an AI's sort of understanding of the world, where do they go? So making sure that's kind of communicated to your wider team is important as well. So it's not just reliant on yourself and your understanding of the system, it's kind of easy for others to work with as well. I mentioned earlier, this has got to run. It's got to be performant, and you can dig quite deeper into this sort of technology in Unreal. You can look at environment query systems. You can look at different types of perception. You can look at different types of AI systems completely, but it has to run. It has to meet that FPS targets that you're working to. So again, it's not a case of making sure that everything is overly complicated and too much information is needed. It needs to be streamlined and work on your platforms. Hopefully, you'll also have a bit of a plan, like I mentioned, with Excel, diagrams.net, flowchart software, all of these things to keep your systems consistent. So you don't want to build an AI different each time you approach it necessarily. Having these sort of modularity aspects to it are really, really important as well, so that again, others can work with your systems, and you also can be sped up a little bit too. So those are some kind of key things to keep in your mind's eye when you're building this, regardless of what the software does or how to use it. Having those things at hand is kind of key. Now, Epic have got some absolutely lovely documentation on building this and starting this within the Unreal Engine. So, please do give those a whirl and have a look at making your own systems. I always recommend starting with something quite simple to begin with, and that could just be an AI that chases a target and then attacks. You don't have to recreate the complex system from your favorite game the first time you play, but try to plan out what each of those systems are going to be responsible for. What are you going to detect? How are you going to make your decisions? And kind of what actions do you want your AI to take using Unreal? So I hope, folks, that gives you a bit of an idea of how you can start working with the software, how you can start building your own AIs within Unreal. I just really wanted to end now to say if there's any questions or anything that folks would like to know.
Cool, thank you, Greg. Yeah, I had a few questions written out, and then you actually answered them all in the last minute. So
awesome.
That was fun. No, I was just going to ask, it obviously sounds it sounds like it's easy to get excited about, and if you're first starting out, there's a lot you can do, and it must be easy to get overwhelmed. So I was just going to say, what advice do you have for people just starting to try this out? Because it sounds like having a plan and limitations is key, and you kind of said that at the end as well. So
yeah, absolutely. I think it's don't go don't go too big too soon, I guess. Get the AIs moving, get them to start detecting targets. All of those fundamental things we'd start with before then going into more complicated things. Often folks are like, I want to make an AI that hides and then it does this. It's like, just do the simple things to begin with. Just look at detection, look at movement, and start building up your systems, really.
Yeah, it sounds like it's something I try to get across to my students of concept art as well. It's really easy to want to dive straight in, but a lot of the time you'll dive in and get excited and then realize that you've run into a load of problems because you've not actually worked it out first. So you need to actually do that first. Otherwise you're just going to waste a lot of time, essentially.
Absolutely. And being able to talk to lots of different people across different teams is really, really helpful here, because the AI's got to mesh with your level designers, your games designers. It's got to work with animations. It's got to work with your combat system. So it's something that you need to be able to talk to lots of different people in your dev team about.
That's something I actually never considered until you said that. I never thought like, oh, actually, yeah, just need to think about the sounds it's going to make, the animations. Can we actually do that and stuff? And yeah, I thought that was a really good point. There was one question in chat as well. So I'll just pop that on screen. So will these slides be available after the stream?
I guess they can be, yeah.
They can be. We just have to figure out where to put them.
That's it, yeah. We just got to figure that out.
So they're accessible, but we will try and figure that out, yes, so that they are available. But cool, that wraps things up, unless you've got anything else you just want to add, Greg?
Well, no, that's lovely. Thank you. And just thanks for everybody for joining us.
Yeah, brilliant. Thank you. Yeah, we had quite a few people watching this, but it was really good. If you've got any additional questions, just pop them in the chat, because they will still pop up and I can shoot those over to Greg afterwards. But other than that, thank you everybody that did tune in, and thank you to Greg for presenting that as well, because it was really cool. But we will finish up now. So everything is obviously available still on the YouTube as well. So if you did miss any talks today, they are still available to watch. But thank you guys for watching. Bye.
Cheers, everyone. Bye.